Hello everyone, I am Shubham and welcome to the channel. In this series, we are going to solve coding interview problems, but instead of just memorizing solutions, we will understand why they work. Now imagine you are in a coding interview. The interviewer asks you to solve two sum. You write the brute force solution, they look at you and ask, can you do better? If you're not sure how to answer that question, this video is definitely for you. So let's get started. Okay, so here's the problem. You are given an array of integers, let's call it nums, and a target value. Your job is to find two numbers in that array that add up to the target and return their indices. So for example, if you have got the array 2, 7, 11, 15 and the target is 9, well 2 plus 7 is 9 and they are at index 0 and 1. So we return 0 and 1. Two things to note here before we write any code. First, the problem guarantees there is exactly one solution. So we don't have to worry about multiple solutions or no solutions. Second, we can't use the same element twice. So index 0 and index 0 doesn't count if it makes to the target. Cool. Let's start with the obvious approach. The brute force is exactly what it sounds like. For every element, we check every other element, see if they sum to the target. This is done in two nested loops. Let me write that out for you. Okay, let's create an outer loop with index I, which starts from 0 and goes till num's length. And then coming to inner loop, we will use index j. And notice it will start from I plus 1, not 0, to avoid using the same element twice. And if nums I and nums j equals target, we have found our pair. We can directly return both the indices here, I and j. And just for a return statement, we will return empty array here. According to problem constraint, we will never reach here. Now, does this work? Let's try running it. Yes, it worked. Will it pass lead code? For small inputs, probably. And yeah, if you see it is accepted. But what's the problem with it? The time complexity is order of n square. For every element, we are potentially looking at every other element. If the array has 10,000 items, we might do 100 million comparisons, and that's slow. And honestly, in an interview, if you give this answer and stop here, you are leaving points on the table. The interviewer wants to see you get to the better solution. So let's do that. Now let me show you what this actually looks like in action. I am going to walk through the array step by step and we will see exactly how the hash map gets the answer. Alright, here's the key insight. For each number in the array, I don't need to search the whole array for its complement. I just need to remember what I have already seen. Let me say that differently. If I'm at a number, let's say it's 7, my target is 9. So I need a 2, right? 9 minus 7 is 2. So instead of looping back through the array to find a 2, I just ask, have I seen a 2 already? And that's exactly what a hash map is for. It provides us a order of one lookup. So only one operation instead of searching through the whole array. That's much faster, right? So here's the plan. I will use a hash map, let's call it scene, to store each number that I have seen mapped to its index. Let me walk through the array step by step. Our target is 9, right? And we start at index 0. The element is 2 here. We calculate the complement, which is 9 minus 2 is 7. Now I ask, is 7 in my map? No, right? The map is empty currently. So I add 2 map to its index 0 and move on. I is 1. The element here is 11. I calculate the complement again. The complement is minus 2. I ask again whether this number I have already seen or not. No, right? Because it's not in the hash map. So I put the element here 11 mapped to its index 1. Now I equals 2. The number is 7. I need 9 minus 7, which is 2. Do I have it in the map? Yes, it's at index 0 that we already seen. That means I found my pair and I return index 0 and 2 here. Now notice here, we only walked through three elements. We did not have to loop back, only one pass was needed. That's the speed difference. Let me say this one more way because it's important. As you walk through the array, your hash map is your memory. At each step, you are asking, does the number I need exist behind me? If yes, you are done. If no, you are leaving a note for a future you in the hash map. Now, let's be clear about the trade off. With brute force, we checked every pair, that's off and square time, but we used no extra memory. Here we are using a hash map, that's extra space, but look what we gain. Basically, we use extra space to buy speed, and this pattern appears everywhere in coding interviews. You will see this trade off pattern constantly. Use extra memory to speed up time. That's the optimal solution. Now let's write the code. Let me start by resetting it. Okay, so let me start by creating a map of integer to integer called scene. Uh, so this will be where we will be storing our values, and I will need to walk through the array nums dot length. This will be our loop. We need to calculate the complement here, which will be target minus current number. And if we have seen the number already, we just return it here itself. Get complement. We need to return index of both. Otherwise, we put it inside the map. And at last, just a return statement. We can return a blank array. So let's try running it. It's accepted, and let's submit it as well. Yeah, it passed all the test case. Okay, so time complexity here is order of n. We are doing one pass through the array, and space is also order of n. In the worst case, we store every element in the map before finding the answer. That's the trade-off compared to the brute force that we discussed earlier. Brute force was order of n square time and O1 space because it did not use any extra memory. Our optimal solution used extra memory to buy us speed. And that's the two sum. Brute force to show you understand the problem, and HashMap to show you know your data structure in an interview. If you are new here, I'm going to be solving coding problems in Java every week, going from easy to hard, and always explaining not just what the solution is, but why it works. If that sounds useful, hit the subscribe button. If you have got any questions about the solution or anything I got wrong, drop it in the comments. I read everything. See you in the next one.